So now let us see this problem. Okay, so consider the circuit shown in this figure. The SPST switch closed at time equals 0 after it had been open for a very long time. And we assume the parameters for these components. So the first problem is that we want to know the IL, ICV, or VC at the time less than 0. So how to do this problem? So at first, you know that because the switch when t less than 0, switch is open. Therefore, and it has been open for a very long time, so we know that C is open circuit. And the L is short circuit. So therefore we can understand that the IL inverse, so is equal to minus 6 ampere. So this is very easy to understand. And because the L is short circuit, so we know that VL0 inverse is equal to 0 volts. And also that because this is a parallel circuit, we know that VC 0 inverse is also 0 volts. And because the all current flowing to the inductor, we know that IC at time less than 0, it is also 0 ampere. So we get these solutions. Okay, so this is the first problem. The second problem, we want to find IL at time equals 0, VC at time equals 0, and the time derivative of IL and VC. Okay, so how to understand this? First, we have to understand one thing is that VL is equal to L dIL dt, and IC is equal to C dVC dt. These two formulas. So we know that the voltage across capacitor cannot change immediately. So we know that VC 0 is equal to VC 0 minus, this is equal to 0 volts. And also the current through the inductor cannot change instantaneously. So we know IL 0 is equal to IL 0 inverse. This is equal to minus 6 ampere. Now we get this information. Now, next we continue to determine I plot L at time equals 0. This is actually equal to the IL dt when t equals 0. So how to get this answer? This is actually equal to the following. Because we know this formulation, so actually this is equal to VL at time equals 0 divided by L. And therefore we can get the following, because what is VL? VL is actually equal to VC, because this is a parallel circuit. And we know VC is equal to 0. So this is equal to 0 ampere per second. Please remember there is a second here. The unit, you have to be careful. So next, what is our VC plot at t equals 0? This is equal to dVc t dt when time at 0. And we know that this is actually equal to this is actually equal to the C IC at time equals 0. But we have no idea about this. So again, from the lecture notes, you know that IR0 plus IL0 plus IR0, IC0 is actually equal to IS. And this is equal to, what is IR0? IR0 is VR0, V divided by R, by Ohm's law, plus minus 6. This IL is defined here. And IC0 is what we want here, equal to IS. What is IS? IS is equal to 6. Okay, so now we can get the following. That is, because VR0 is 0, so this is 0, so IC0 is equal to 12. This is equal to 12 ampere. So we know that this is equal to 12 ampere divided by 3. And this is equal to 4 volts per second. So now we find all answers here. Okay. Now the last problem is problem C. What we want to do here is that we want to find the expression for IoT. So how to do this problem? Now we close the switch. So again, you can find this by IL plus IR plus IC equal IS. And now you can form, you can take the derivative of this and form the homogeneous second order ODE. So you will get the following, that is IL double plane plus 1 over RC IL plane plus 1 over LC IL equal to, that is 0. And then you plug in the number you want, you get IL double prime plus 1 over RC, which is 1 over 4 IL prime, plus 1 over LC, that is 1 over 64 IL equals 0. And then you can check that this is critically damped. So you can find that the root is equal to S1 equal to S2 equal to minus 0.125. So I skip this trivial step and you can check it at home. So what the solution IT is equal to the I infinity plus A1t exponential minus 0.125t plus A2 exponential minus 0.125t. So what is I infinity? So the key point for this is we are interested in I infinity. I infinity is the following. So when time goes to infinity, we know that this is short circuit, this is open circuit, and the current won't flow into this. So you know that you can view this as a 0 volts. So the current flow into this way is equal to 48 volt divided by the R1. R1 is equal to 4 ohms. So this is 12 ampere. And you know that this is 6 ampere. So the current flowing to here is 6 ampere. So this is the I infinity. And then you get this. So now you can find that this is IL. So IL at time equals 0 is equal to A2 plus 6. And this is equal to minus 6. You can find this answer from here. So you get A2 is equal to minus 12. And then what is IL at time equals 0? Plot, you take the derivative of this. You can get this is 0. And this is from here, what we found here. So this is equal to the following. This is equal to A1 minus 0.125 A2. And this is also 0. So you can find A1 is equal to minus 1.5. So now you get everything.